let me know when we're live. All right. Hello, everyone. Welcome. This is Thomas Logan from Equal Entry, the founder of Accessibility Virtual Reality. Happy to have you all here today. We have not had a group meeting since about August, so it feels great to be having a new presentation with you all in December. And we are looking to, again, have this meetup happen more frequently in the new year. So anyone that's joining us today, if you have a topic, if you're interested in accessibility and virtual reality, augmented reality, extended reality, please reach out to us. We are looking to build our schedule for next year. Today, we want to say thank you to Jolie McPhee from the Accessibility Special Interest Group of the Internet Society of New York for providing our live stream on YouTube. Everyone here that's joining us on YouTube, we do monitor YouTube and we will take your questions or comments from the stream live today and ask our presenter. And also just for the posterity of our events, everything that we do at Accessibility Virtual Reality is archived on our YouTube webpage. So it's just youtube.com/A11yVR. Today, we also want to say thank you to Kimberly Shea from Breaking Barriers Captioning Services, LLC, for the captioning today. Our events, we have human captioners, and that's why we have such high quality captions for our events. And we will also, as part of our process, review the captions that come from our events, and we work to publish those on our YouTube page and make sure we have the best transcript we can have. Thank you to Merrill Evans for helping us organize these events, and also just acknowledging the sponsor, my company, Equal Entry. We're an accessibility consultancy that helps companies ensure their products and services are accessible. And especially for today's event, we're really interested in virtual reality, extended reality, and augmented reality apps. I'm so excited to present Christian Cousquer, an ICT specialist in web software engineering at the National Conservatory of Arts and Crafts in Paris. When I met Christian and saw all of the different work that himself and his team have been making, I was like, this is going to be such a great presentation. So really excited to hand it over to Christian, and we will be monitoring your questions during Christian's talk, but they will all be asked at the end of his presentation. But thank you very much, and over to you, Christian.
So, hello. You can grab the presentation at this address here. If you have any problem in distinguish contrast, you feel free to configure the display of this presentation here, and you will see it will change. You can change the font type. You can do lots of things for your accommodation. So, challenge of implementing accessibility in a digital twin in virtual reality of a chemistry lab. I have a subtitle: Designing an accessible digital twin in virtual reality. It's like sending astronauts to the moon and creating a lunar base. And you will see why. So, in this presentation, I do hope you will learn strategies for designing and managing digital twin in virtual reality for learning.
Christian, sorry to interrupt you. I'm sorry to interrupt you. The stream is not going live on YouTube right now, so you need to pause for a moment.
Okay.
Sorry. So we want to make sure we have the audience tuned in, and it's Julie, can you let us know? And then okay. Okay. So we have the recording. So actually Christian, just take us just jump right back in. Sorry about that. And welcome everyone on YouTube. We were having a slight difficulty here at Accessibility Virtual Reality Meetup, getting our stream going on YouTube, but we're really happy to have you here now. And we had just gotten into the presentation for Christian.
So my
Christian, I'll hand it to
slide, you can have my presentation at this address. If you have any problem with contrast perception, you can change the things like that here, and it will change the display of the presentation. So feel free to open the configuration and set what the things you want to have. So challenge of implementing accessibility in a digital twin in virtual reality of a chemistry lab. Designing an accessible digital twin in virtual reality is like sending astronauts to the moon and creating a lunar base. So in this presentation, I do hope you will learn strategies for designing and managing digital twin in virtual reality for learning, strategy for pedagogically scripting VR content, and I have a big part on addressing virtual reality accessibility challenges. You will also discover a digital twin of a chemistry lab called Mimbus Chemistry. And I do hope you will learn how and when to use VR content in your teaching. And also you will improve your skills in Franglish. I do hope you will discern some meaning in the mixture of words that come out of my mouth because I'm French. And so, introduction. My name is Christian Cousquer. I'm working in the field of digital accessibility since 17 years now. I'm an accessibility and an immersive technology consultant in my own company called A11yVR, and I'm an ICT expert at the National Conservatory of Art and Craft in Paris. And formerly, I was a comedian, a professional comedian. So, the National Conservatory of Art and Craft is a public higher education institution specializing in lifelong vocational training. It was the only higher education institution funded during the French Revolution. It was funded by an abbot, Grégoire Abbot, and we have also a museum in our university where you can find a replica of the Liberty Statue and splendid rocket engines. And we have two mottos. The first one is we must enlighten the ignorance that doesn't know and the poverty that doesn't have the means to know. And the second one is in Latin, omnes docet ubique, teaching everyone everywhere. This is the very heart of our institution, and we are going to insist on those two terms, everyone and everywhere. So, what is a virtual digital twin for learning? It is this. Oopsie. So, this is the chemistry lab in virtual reality. You have a virtual tour. You can open tool type. You can grab everything in the lab. You can do experiments, reflux heatings experiments, liquid extractions, rotary evaporation also, and you can train a lot. We have about 3 hours and a half of different experiments. You can be put in danger, and learn how to use an eye washer, by example, and you learn the ability to select the right personal protective equipment, and you can recognize risk, deals with the information, and do a small gesture like a thin layer chromatography. It's an attractive solution. It's optimized laboratory occupancy, and you can learn a lot with it. And virtual reality is a powerful teaching medium. VR can offer a more visceral experience than traditional screen-based media. In a sense, it can appeal to the user's spatial memory, give them a sense of scale, and in many cases serve as an emotional amplifier and a memory of the experience. You said, I had an immersive experience. You don't say that I had an educational video because it tapped in another brain region, the live experience region in the brain. So this interactive component has advantages and disadvantages, and striking a balance between immersion, ease of use, accessibility, and experience is the main challenge of virtual reality design. You have here an immersive practical course at the National Conservatory of Art and Crafts on the picture. And you need to differentiate between virtual and immersive practical session. A virtual practical session can be done can be a 3D animation on screen. An immersive practical session uses virtual reality headsets. It's an active pedagogy. The learner are spect-actor. And the virtual reality headsets create the sensation of being transported to another world. But in immersive learning, there is a hidden word. Immersive refers to immersion plus body in action. It gives the learner an active presence. In learning, you have apprenticeship of skills, know-how, soft skills, plus feedback. It gives you learning interest. But between the body and action and the feedback, there is the interactivity. It is because the learner is in action that the computer, the simulation, is answering him feedback. And because there is feedback, there is the learner will respond to those feedbacks by actions. Learning traces gives you learning analytics. We have a learning management system for VR, and it gives you also for the teacher, he can evaluate the progression of the learner. So let's go deeper. How to design? Focus on your plan. You need to define a strategy. And I can give you an advice. Take a baby step-by-step strategy. Each stage of your project must benefit from the previous stage of your project, both from an educational and a project management point of view. And for example, for the chemistry lab, we have two partners. One company for the development called Mimbus. They are really cool. They are top developer. It's one of the best company for VR development I know. And we have the Immersive Learning Lab, which is a lab dedicated to immersive learning. And we have a partnership with them to acculturate the teacher to VR. So we have a starting phase, we have a requirement phase, and we knew that we want to have a realistic environment. So we began very early the development of a 3D computer graphic. After that, we have an acculturation to VR of the teacher. This is a very important phase you will see after. And after that, we have screenwriting of the first virtual reality module. So request scoping phase. Every project, every educational project has his own pedagogical objective and specificity, and therefore their own technique and management phase. For Mimbus Chemistry, we want to focus on the learning of professional skills, hand gesture skills, and processes involved in chemistry experiments. So our specification are really simple. We want a tutorial for learning how to use the VR controller. We want the learner to learn skills, hand gesture, the processes involved in chemistry experiment, how to use equipment in a chemistry lab. So we need to focus on the teaching scenario. The technique will follow, and the interactivity component will be fundamental. We want a realistic environment. We want full internationalization in French and English. And we want to focus on usability and accessibility whenever possible. So this simulation has, for the moment, 3 chapters. We have a tutorial, we have a virtual tour, we have a safety chapter, we have a chemistry experiment chapter, and we will have a digital twin chapter where there will be sensor on equipment in the lab, and we will send data to the simulation after. Let's see of also something's very important in the project management point of view. We do not want to have a traditional top-down structure like this. We want to organize ourselves like a teams of teams. We want to have in our team, we are about 25 teacher, engineers, developers, project manager, instructional designer in our team, and we want to have collective intelligence. And so I gave you the definition of the collective intelligence, and it's a learning organization. We learn a lot from each other, and that's very important. In a traditional top-down structure or a command of teams, there are problems in communication between those group or those group. So this kind of organization fits very well to virtual reality development. So the VR acculturation phase of the teacher. A VR project is first and foremost a writing process. You can have the best teacher in the world. If he doesn't have put a virtual headset on his eye, if he is or she is not acculturated to virtual reality, he won't be able to produce anything in VR. And on the other hand, VR content producer often have no expertise in educational scripting or in the progression of knowledge and skills acquisition. In VR, everything must be formalized in writing. And as an example, Mimbus Chemistry specification is about 300 page now because we deals with scenario, scenography, storyboarding, and design thinking. A teacher, a content expert needs to know a few things. He needs to identify the impact of virtual reality in training. He needs also to understand very well the nature of immersive medium and the physiological, psychological, and cognitive mechanisms on which virtual reality is based and which underpins its effectiveness. So lift off. Let's go deeper. The first stage of the rocket, you need to define the virtual environment. It's like in a game. Uh, you need to let the user discover the lab. And so we create a first module, a virtual module, a virtual tool module with tool type and the danger addressed by some equipment. Next, another module for the identification and the characterization of the environmental equipment. It's a kind of treasure hunt. It's more difficult. You will say to your learner, okay, you have discovered in the first module the lab. Now go in the lab and identify and characterize some equipment in it you have discovered before. Many teachers are doing mistake in this module also. It's very difficult. The second stage of a rocket, make small reusable module. And we have made small safety procedural learning module with virtual endangerments. One of the strengths of virtual reality, it's its ability to reproduce dangerous situation in complete safety. So to do that, we break down the procedure into step-by-step scenario with branches. You can smell poison. You can face fire danger in the lab. And to do that, we have developer, we have teacher, chemistry teacher who don't know development. We have instructional designer, and we need to find a kind of common language between us. So we are doing BPMN diagram has a scenario where every action are decomposed into unit tasks. You need to do that. Then after the user needs to do that, he needs to go there and go there and go there to achieve the module. You see, and a teacher, a chemistry teacher can read this. A developer can understand those diagrams to put those diagrams into code. So that's very important to have those kind of things. The third stage of the rocket, it's make module that can reuse the previous module. So we make chemical experiments in which we can replay the small safety procedure module at any time. I'll give you an example. A user is doing a liquid extraction, but he is doing a mistake. There is a glass which fall on the ground and who's breaking. You can replay the safety scenario of light cutting because you have already developed it before. And during all this process, we have interactivity challenge, and we need to solve an expected problem and addressing accessibility. So, one of the specificity of virtual reality development, it's that it's quite the reality. It's not, it's a virtual reality. It's quite the reality. So you do not try to reproduce reality at any cost. You need to find interactivity metaphor while always focusing on usability and accessibility. And to do that, uh, you need to work with simple question. How do you empty or collect contents from a container with a spatula when you have VR content in your hand? How do you wash a dirty spatula? How you deals with flexible houses in VR? And I can give you an advice. When something is done in 2 seconds in real life, it must be done in 2 or 3 seconds in virtual reality. And let me show you how we use the joystick to empty or collect content in the lab very easily and very quickly. So I grab the spatula and then I trig up the joystick or trig down to empty it, and you can do now. You can mix content very easily, like that. You see, it must be very easy. We do not have to calculate the position of the spatula. We just we just put the spatula on the top of a container and we just trigger the joystick. You can see that every equipment is functional also. So let's talk about accessibility in virtual reality. Accessibility means enabling people with disability to fully enjoy their right and fundamental freedom by removing any barriers they may encounter. And digital accessibility in virtual reality and in extended reality is a field of research. As for me, it's a kind of combination of web accessibility and video game accessibility. And very important, with its own specificity. It's not entirely the video game accessibility. It has its own specificity because of the viscerality of the medium. And there are documents of the web by the W3C Extended Reality Accessibility User Requirements. You have the links here. The BBC has write very important research also, and there is most of all XR Access, who has done a tremendous work also. So, how do we address accessibility? We provide our user a tutorial in order to familiarize him with the available interaction. The aim of the tutorial is to teach the user the command of the virtual reality equipment, the different metaphor used in the application in a clear and progressive way. Uh, it must take place in a neutral and uncluttered environment, so has no not to distract the user from the various action expected. And the tutorial is presented in the form of successive team room, which the user will have to validate one after the other. Teleportation, moving around, grabbing an object and moving an object, and interacting with an object. You will see the tutorial in 2 minutes. You need also to provide your user different level of difficulty, a beginner mode, an advanced mode, and an expert mode. Beginner mode is the user has lots of information to achieve the exercise. In the expert mode, he has just one instruction: do this experiment. And you can he must do it. Addressing hearing. Every spoken instruction by a voiceover is reproduced in in writing on a wrist mounted tablet. You can see on the right. And with this, a deaf student was able to pass all her exercise in a practical immersive chemistry session. We choose to have a wrist-mounted tablet because we for two things. If he needs to have an instruction, he needs to do some things to read. He needs to do a gesture to read it. We don't want to break the immersive sensation by having text on the virtual environment. And we want also to have a clear contrast difference between the background of the text and the color of the text. So we use a wrist-mounted tablet. Addressing motor impairment. All chemistry module can be completed in a wheelchair. It's very important to have lazy developer who don't stand up for testing things and who are testing things uh, uh, on a chair. And when an object falls on the ground, it can be picked up without bending down thanks to magic grab laser. You will see it here. You see the laser and we grab very easily without bending down too much. And if I take a spatula, you will see now, and I drop it on the ground, I can grab it very easily. More complicated, addressing color blindness and dyslexia. We have in our simulation three possible actions with the hand controller. Teleportation, which we associated with the purple color at the first room in the tutorial. Grab an object, what we associate to the blue color, and activate an object which is associated with the color yellow. The choice of this blue and yellow color was made because a person having color blindness will always distinguish yellow from dark blue. But we also realize that about 10% of our students confuse their index finger with their middle finger on their hands. So we imagine some magic rings that will associate the right color and therefore the action to the right finger. And the third option are filter of color according to the type of color blindness, protanopia, deuteranopia, and tritanopia, which change completely the color of the environment and the ring also. And the last option address dyslexia by changing the font type for adapted font. So let's see what it looks like. So you see, at any moment you can change the parameter. So here are the magic rings, and we can now change the theme of the text, and we can use the color filter for protanopia, deuteranopia, and also the tritanopia, and there is a slider of intensity. And now we can also change the font, and you will see that the color change, and there is a perfect combination with the color filter. It's always understandable for someone who have color blind. Addressing color blindness part 2. The information must not be given only by color, and you will see here again the magic ring. We have also people who were looking at the top of their wrist, the tablets, and some other at the bottom. So the tablet is always readable and operable. So let's see the lab has someone who has tritanopia. I will answer a quiz. I will make a mistake and a good answer, two mistakes and a good answer. So you see perhaps the error and the good answer. But now, if I have the tritanopia filter, you won't be able to distinguish a good answer and a missed answer. But you can, it's always, you can see that the information is not lost. Things to come in accessibility in the chemistry lab. We want to address the Proteus effect. The Proteus effect describes a phenomenon in which the behavior of an individual within a virtual world is changed by the characteristic of their avatar. I give you an example. If I have an old man hands in virtual reality, I will walk slowly. And well, we have a Proteus effect in the lab. Women with virtual male hands have a strangely brusquer gesture. So we want to give the ability to the user to choose between male and women virtual hands. We want also to suggest an alternative to holding down two long time keys. And for the grab action, we will, as an option, give the user the ability to one click to grab and a second click to release the object. We want also to give the user the ability to modify their input preference. The remapping of key used to control movement and interaction in virtual environment is more complicated than it seems, because it involves modifying the entire experience dynamically, including the tutorial, according to the user experience. So we will do it, but it takes a few weeks to develop this. And striking a balance between immersion, ease of use, and experience is the main challenge in VR design. All these accessibility settings have been built by, tested with, and for people with disability. And they are open source also on GitHub. Another things not related with accessibility, it's usability. We are also testing every module with young kids for usability because to see if without any help a boy or a girl can do them. Here we are testing the ease of use and the understandability of the lab exercise. So let's see a young kid, a 12-year-old young kid in the lab. It was its first time in in virtual reality, and 10 minutes after, he was reacting like this. Also, it's a gamer also, so you can see he's he can do things very quickly. And that's quite cool to see that. So let's see uses in classroom. If designing a virtual reality chemistry lab is a project, deploying it in the classroom is another project. So first of all, VR for which discipline to develop which skills. If you need to learn professional gesture in technology, hard science, medicines, in VR you have immersive simulation, VR module. If you need to learn soft skills, uh, all teaching disciplines using role playing, you will deal with avatar, interview simulation, etc., etc. You can also learn foreign language learning in virtual reality. And virtual reality is also very good for immersive visualization of 3D calculation for mathematics and hard science. Where to place a VR module in an existing curriculum? We found that potentially you can put virtual reality everywhere. In autonomy, upstream of a course has a support of a course. After the course has knowledge reinforcement and also has an evaluation. Has an evaluation because we have a learning management, an open source learning management system for VR called uh, Mimbus Vulkan. And also for accessibility, we can say this user uh, needs to have more time to achieve an exercise. And we can set this parameter into Vulkan. And this user will have more time to achieve his exercise in VR. So, well, I'm finished. So I thank you for your attention and I'm open to your questions.
All right. Thank you so much, Christian. This was awesome. We have questions now from YouTube. So I'm going to bring those to you and we'll just go through them one by one. First question. Given a chemistry lab has multiple sensory inputs, including olfactory, how are these being integrated to maximize the learning experience? Have there been challenges allowing people to use alternate input methods besides controllers?
Um, for the moment, we are looking perhaps to see if we can use other controllers, but it's very difficult because we need to have end gesture and 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 uh, if I take an Xbox controller, I do not have a gyroscopic sensor to have the position of their hands. It's very delicate for us to use such kind of controllers. We need to have VR controllers for the moment, and it's a big reflection we have.
Okay, another question we have from Oscar. Can you display or explain the design of the magic rings and just go over that design a little bit more?
Oh, it's very simple. We found that we have a learner who were clicking with their index finger and middle finger quite like crazy people. And we want to help them to say, oh, when you interact with this object is highlighted in blue, so you can grab it. So it's the middle finger. So use the middle finger. And he grabbed it. And we found that it works. It works very well. Perhaps we will add some sound when the very delicate to indicate that this object is grabbable, this object is activable. You see?
Yes. All right, great. Thank you. Next question. Have there been any challenges allowing people to use alternate input methods besides the controllers? Just any feedback on what you've learned from if they're not using the default controller?
Oh, it's again, it's very complicated with other controller than a virtual reality controller to have the position of the hands in the virtual environment. We do not want to click on a button to do a movement of the hands. It should be some things uh, done with the hands, with the hands. I'm not sure if I'm clear with that, but uh, one of the goal of the chemistry lab is to learn hands skills gesture. You see, so the hands needs to move in virtual reality, not to click on the button. It will be a nonsense for us.
Right. I think maybe that if you can pull that slide up again too, but you have a slide
Yeah,
with all different error
yeah,
conditions that can
yeah.
occur in the lab. Maybe maybe we
I
can
need to
describe
share
it.
my screen here and see if I go and where is it? Addressing earring, color blindness. Yes, it is here.
Okay.
Uh, so in the tutorial, you see there is a picture on the wall where we indicate the interactivity, grab an object, interact with an object. And you see the ring color, the colored ring. The laser is now yellow or pink, and the ring will be always at the same color. You see?
Yes.
Grab an object. It is green now, and the ring is green also. To activate an object, it's pink. So you need to choose the index finger, pink. The laser is pink there, and it works.
Great. That's perfect. So we'll go to our next question. Thank you. So next question, how can people outside the experience best see and communicate with the people inside? Any consideration for co-piloting or annotation?
I can share you something.
Okay.
I have on my computer a video of an immersive practical course. I will show my screen. Ba, ba, ba. Where is it? It is here in video. And it's chemistry PP, this one. We are doing practical works. Uh, you have here, I will just cut some things will cut the sum. And let's see. You have a student with a virtual headset, and another student is with him. And this student will give clue to this one, and their work in binom, their work together. He is working in the beginner mode, and after that, this one will be in expert mode, and he will be helped by the first one with the knot of the second. You see, he is not alone when he is in virtual reality. A student is not alone. I'm quite sure of that. And you have the teacher here behind who is looking to every student and who is doing a feedback session after that. Is it uh,
No,
is it
that
something clear for you?
that's great. We're going to go to the next question. So the next one was, how much work was it to change inputs to like work with one-handed or think about the control remapping? Like how much work was that?
Oh, I don't know how much work it takes. I'm quite sure that in 3 months we will have the remapping.
Okay, sorry. Yeah, no, that makes sense. It's like hard to make it an app.
We have a planning, so we have pre we need to develop. We have about 7 hours of experience, different experience to develop.
Yeah.
So we need to develop modules. We need to develop in accessibility. It's some things step by step.
Yeah, maybe, and that'll be my last question for tonight's presentation. Thank you so much. I think yeah, I'm curious. Your implementation has so many accessibility features. For me, like when I met you, I was like, wow, like you're implementing a lot of these features. Could you just talk about how you're able to prioritize that and maybe recommendations to people outside of your environment, but just how can you get people to think about this and make progress because you clearly have.
Um, to help the other people to design and develop accessibility in VR, you need just to think it's accessibility is not a constraint. It's an opportunity to innovate. We have people have invented smartphones for and touch screens like this for people with disability. During the First War, the medicine has made tremendous invention with the guy who were wounded by the war. So it's an opportunity to innovate. And it's after all, it's a civil right. You need to do it. You see, it's you don't have to ask questions, to wondering, should I do accessibility or not? You need to do it. And it's you have so many people with some disability that it's also a marketplace for you. And I do not know companies who will say, well, 20% of my market don't interest me. It's You need to address accessibility and to fight for that.
All right, Christian, so well said. Thank you so much. And thank you for like all of the work you're doing. Invite everyone here on the YouTube. You can connect with Christian on the links that were shared in the presentation, and we'll also be sharing this out on the Meetup page and Equal Entry website. But again, thank you so much, Christian. This was a great presentation, and thank you for all the work in really building it, not talking about it.
I do hope you have understood me because my accent is so awful.
No, I think it's, well, for me, it's very charming. I think most of our viewers will agree. It's a great accent. Sounds nice. And we also want to say thank you to Jolie McPhee from the Accessibility Special Interest Group of the Internet Society of New York and Kimberly Shea from Breaking Barriers Captioning Services, LLC, for our human-generated captions today. We're thankful for you all to all join us today. Please follow up with us and Christian directly. We will be having more events, as I said, in 2024. So if you were inspired from Christian's presentation today, please reach out to us. We're going to try to be having these events more regularly in the new year. Thank you, everyone. See you next time.